Hello everyone, welcome to today's session. Today we'll go continue the problem of the interval minus L12. We have completed one problem. So this is the second problem. Obtain the Fourier series expansion when f of x is equal to 2x square plus 5x and 2x square minus 5x with the two given conditions in the interval minus 2 to 2. So let's solve this. Here we know that the value of L is 2. And now first we need to consider the phi of x function. So now first step is we need to replace the value of x by minus x. 2 into minus x square plus 5 into minus x. That will give you minus x the whole square is x square plus into minus minus 5x. So here the resultant we got is equal to the xi of x value. Phi of minus x is equal to xi of x, then we say that the function is even. In even function we know that the value of bn is 0. We need to find a0 and an. So now we'll find the value of a0. Substitute the values. The value of L is 2. So 2 by 2, 0 to 2. From the interval 0 to 2, the value of we need to consider the value of xi of x, that is 2x square minus 5x. X square minus 5x. Now this 2 gets cancelled. 0 to 2, 2x square minus 5x dx. So this becomes 1. So now substitute the limits. First integrate the function. X square by 2 from 0 to 2. Substitute the upper limit, that is 2. 2 into 2 cube by 3, that is 2 into 8 by 3 minus 5 into 2 square, that is 2 square is 4, 5 4s are 20, minus the lower limit. We'll get it as 0. 2 into 0 cube by 3 is 0 and 5 into 0 square by 2 is 0. So it is 0. Here also 2 1s are 2 10s are. So the final answer is 16 by 3 minus 10. So let's simplify this. 16 minus 30 by 3. We'll get minus 14 by 3. So yeah, this is the value of a0. So now similarly we'll find the value of an. Value of L is 2. F of x is 2x square minus 5x cos n pi x by 2 dx. This becomes 1. So now integrate the function, apply the Bernoulli's rule. It becomes 2 into x square. Differentiation of x square is 2x. So it becomes 4x. 4x minus 5 the first function we need to keep it as it is. Into the integration of the second function, that is integration of cos is sine n pi x by 2 divided by n pi by 2 minus we need to differentiate this first function, that is 4x minus 5 into the differentiation of sine is minus cos n pi x by 2 divided by this square, this term's square, that is n square pi square by 2 square, that is 4. Again plus we need to again differentiate this function. It becomes differentiation of 4x is 4 and 5 is 0. Again the integration of this function. Integration of cos is sine again, so minus cos, so minus sine this cube, so n cube I cube by 2 cube is 8. The limits are from 0 to 2. So now we'll substitute the limits. 2 by 2 is 1, so we will not write that. 2 into 2 square minus 5 into 2. 2 into 2 square is 4, that is 8, minus 5 2s are 10. Sine 2n pi by 2 minus 4 into 2 minus 5, 8 minus 5. Minus cos 2n pi by 2 n square pi square by 4 minus 4 sine by 8. This was just the upper limit. So now we'll substitute the lower limit. 2 into 0 square minus 5 into 0, that is 0. So the whole sine term becomes 0. Minus 4 into 0 minus 5, that is equal to minus 5. Into minus cos 0 minus 4 sine 0 divided by n cube by 8. So here we can cancel out some terms. This 2 gets cancelled in all the terms, and even this if 2n pi by 2 gets cancelled, the value is sin n pi, and we know that sin n pi is 0, so this whole term will become 0. Similarly, this term will become 0 and this term will become 0. The value of sin 0 is 0. So there are only 2 terms left, this and this. So now let's put them together. 8 minus 5 is 3, and there is a minus sign outside, so it becomes minus 3, and minus into minus is plus. So I'll write it as 3 cos n pi divided by n square by 4, and this one again minus into minus is plus, plus 5, plus into minus is minus, again minus 5, again there is a minus sign outside, so it becomes plus 5, and into cos 0 is 1, so plus 5 divided by n square by 4. So now here the n square by 4 is common. After taking common, take its reciprocal and take that outside. 1 divided by 4 divided by n square pi square, take that outside and write the remaining terms. 3 cos n pi plus 5. So yeah, this is the final answer we are getting. 3 into minus 1 to the power n plus 5. So this is the required value of an. So now we'll write the Fourier series. So here we got the Fourier series by substituting the value of a0 and an. The value of a0 is 14 by 3, a0 by 2, so it becomes 14 by 6. We can further simplify this. The value of this becomes now minus 7 by 3, and this is the value of an, and say this is the Fourier series. So we have discussed the problems related to minus L to L intervals. The same way in this session, now we are going to discuss the problems related to 0 to 2L. There are 2 problems, one is for discontinuous and one is for continuous function. In the interval 0 to 2L, we know that we need to take the value of f of x, as I have told in my explanation. The value of we should replace the value of x by 2L minus x. So here we need to be very careful by taking the intervals, and also to find the L value there is a small procedure. So I'll tell you that procedure during the problems. So now we'll get to it. So yeah, this is the problem related to the interval 0 to 2l. So the question goes like this. Obtain the Fourier series if f of x is equal to 2 minus x in the case 0, in the case where x lies between 0 to 4, and x minus 6 where x lies between 4 to 8 in the interval 0 to 8. So the first thing is that we need to find the value of L in this case. So we know that the interval is from 0 to 2L. So sometimes the students will get confused and they'll write the value directly as 8, L is equal to 8. We should not take it like that. We know that the interval is from 0 to 2L, 2 into L. So in the place of 2L there is 8. So first we need to simplify that. So 2L, right, is equal to 8. So what becomes L? L is equal to 8 by 2, that is 4. So here the value of L is 4, not 8. So please don't get confused. So like this we need to find the value of L, and we have got the conditions. So the same thing, here we need to replace the value of x by 2L minus x. So now we'll do it 2 into 4 minus x, that is we need to replace the value of x by 8 minus x. So we'll do that. Two minus 8, minus into minus plus, it becomes minus 6 plus x. Also we can write it as interchange the signs, interchange the position, it becomes x minus 6. Here we can see that it is equal to xi of x. So the function is an even function. So now we found out that the function is even. In even function we know that again the value of bn is 0. We need to find a0 and an. Yeah, so now we need to find the value of a0. Substitute the value of n, 4, 0 to 4. From 0 to 4 the function is 2 minus x. This becomes 1 by 2. Integrate this function, 2x minus x square by 2 from limits 0 to 4. Substitute the limits, 2 into 4 minus 4 square by 2 minus the lower limit is 0, so anyways I'll write it as 0. 1 by 2, 2 4s are 8, minus 4 square is 16 and 16 by 2 is 8. So 8 minus 8 is 0, so the whole term a0 will be equal to 0. So now we'll find an. Yeah, so now we'll find the value for an. Substitute the limit. The value of f of x is 2 minus x and pi x by L is 4 dx. Again this becomes 1 by 2. Now use the Bernoulli's rule. First function as it is, integration of second function, integration of cos is sine, n pi x by 4 divided by the coefficient of x n pi by 4 minus the differentiation of this function. Differentiation of 2 is 0 and differentiation of minus x is minus 1. The integration of sine is cos n pi x by 4 divided by the square of this term. 4 square is 16. So now write the limits from 0 to 4. So now substitute the limits. 2 minus 4, the upper limit, sine 4 n pi by 4 divided by n pi by 4. Minus into minus is plus, plus 1 and minus, so I'll write it as minus cos 4 n pi by 4 n square pi square by 16 minus the lower limit. 2 into 0, 2 minus 0 is 2 into sine 0 divided by n pi by 4. We know that sine 0 is 0, right? So I won't write it again. I'll directly write it as 0 minus cos 0 divided by n square pi square by 16. So now we'll cancel out some terms here the same way. This 4 will get cancelled. Again this 4 will get cancelled. So here the remaining term is sin n pi, right? That sin n pi is 0. So this term will become 0. Only these two terms remain. We'll write them minus cos n pi divided by n square pi square by 16 plus cos 0 is 1. Minus into minus, right? So it becomes plus 1 divided by, so the same thing again, the denominators are same. We'll take the reciprocal and we'll take it out common. The value of cos n pi is minus 1 to the power n, and there is a minus sign, so we can write it as minus 1 to the power n plus 1. Plus 1, because there is a, we took this outside, right? So 1 remains. Here again 2 1s are 2 8s are. So the final value of an is 8 by n square pi square minus 1 to the power n plus 1 plus 1. So this is the required value of an. So now we'll write the Fourier series. So this is the required Fourier series. So the value of a0 is 0, so I have not written it. This is the value of an, and the value of bn is also 0. So this is the Fourier series, and also there was a sub question for this, that is deduce pi square by 8 equal to 1 plus 1 by 3 square plus 1 by 5 square. We have done these type of problems in the interval minus pi to pi. So there are a few problems where these cases are there. We'll do it so that you people will be cleared about the concept. So now we'll do that. For this case, so first we need to split the Fourier series as you have done before. So first we'll write that f of x is equal to, take the constant term outside to remove the summation, that is 8 by pi square. So now one by one we need to substitute the value of n from 1 to infinity, that is minus 1 to the power 1 plus 1 plus 1 by 1 square cos n pi x by l, right? So value of n is 1, pi x by value of l is 4 plus, now the value of n we need to write it as 2 square 2 pi x by 4, it becomes pi x by 2 plus, now the value of n is 3 square cos 3 pi x by cos 3 pi x by 4, and this series goes on. We'll simplify this. Now f of x is minus 1 to the power 1 plus 1 is minus 1 square, and minus 1 square is plus 1, and we have another plus 1 there, so we'll write it as 2 by 1 square cos pi x by 4 plus the next term will become 0. See how it is, minus 1 to the power 2 plus 1, that is minus 1 cube, that is again minus 1, and along with that we have the plus 1, so minus 1 plus 1 becomes 0, divided by 2 square, so it's 0, and the whole term becomes 0 there. So the all even terms, right, will get vanished. So we will not write those even terms, only the odd terms we are going to write. 2 by 3 square cos 3 pi x by 4 plus, again at the even term will go 2 by 5 square cos 5 pi x by 4. This is the remaining series. So now we need to substitute the value of x as 0 in this series as we have done it before. For that we need to find the value of f of x, that is f of 0. So according to one note we have written in the starting sessions that whenever in the discontinuous function we need to find the value of f of x. In this case the formula is phi of x plus xi of x by 2. We've written a note according to that. So here we need to substitute the value of x as 0 and we have to write f of 0 equal to phi of 0 plus xi of 0 by 2, but I have not written it. Why? Because the xi of x term, right, in this case the xi of x term, if we substitute the value of x as 0 in this term, like we'll substitute the value of x as 0. I'll show you an example. We are taking the value of x as 0, right? It becomes 0 minus 6. The answer is minus 6. Does minus 6 satisfy this condition? Does minus 6 lie between 4 and 8? No, right? So here, while substituting the value of x as 0, the condition does not satisfy the given question. So we need to ignore that term. That is, we need to ignore this. We need to only consider this. So now here let's substitute the value of x as 0. 2 minus 0 is 2. 2 satisfies the condition. 2 lies between 0 and 4. So directly we can write the value of f of 0 as 2. See, we have written it. The final value of f of x is 2. So in place of f of x now we need to write 2. We'll continue the problem. 2 divided by 1 square cos 0, right? Pi into 0 by 4. So this becomes cos 0. Same thing, all the term will become cos 0. So cos 0 is 1. No need of writing that. Now take the 2 term is repeated here. Take that outside. This is 8 by pi square. 8. So this becomes 16 by pi square. We take outside. 8 2s are 16. So now take this term to another side. So this becomes 2 pi square by 16 comes to the denominator. So here we got the required answer. We got the proof. Now we got right. Pi square by 8. Now we won't tell that it's wrong. Okay. So this is the required series. So yeah, this is the second question. So first problem we have solved is related to the discontinuous function. This is a direct question. The interval is given from 0 to 2. We need to remember that the interval is from 0 to 2L. So again, to find the value of L, 2L, in place of 2L it's 2. So L will be 1. So here in this case the value of L is 1. So now replace the value of x by 2L minus x, that is 2L we know that it's 2. So 2 minus x. 2 into 2 minus x minus 2 minus x the whole square, that is 4 minus 2x minus, we need to use the identity a minus b the whole square, that is a square, that is 2 square is 4 minus 2ab, that is 2 into x, it becomes 4x plus b square, x square. So multiply this minus sign to all the terms. Minus 4 plus 4x minus x square. 4x minus 2x is 2x. 4 minus 4 goes So the required term is 2x minus x square. It matches with the term f of x. So f of 2 minus x is equal to f of x. So again in this case the function is even. So now again, if the function is even, we know that bn equal to 0. We need to find the value of a0. The formula for a0 is 0 to L f of x dx. So this is the formula for a0. So now we'll find the value of a0. So yeah, I have substituted the value of L, 0 to 1 f of x dx. 2 by 1 is 2. So now integrate this function, that is 2x square by 2 minus x cube by 3 from the interval 0 to 1. Here 2 gets cancelled. So to substitute the upper limit, 1 square minus 1 cube by 3 minus the lower limit is 0. a0 is 1 square is 1 minus 1 by 3. So a0 will become, multiply this, 3 minus 1 by 3, 3 minus 1 is 2, 2 into 2 is 4. So the final value of a0 is 4 by 3. We will find the value of an. Yeah, so this is the formula for an. I have substituted the value of L, that is 1. I wrote the f of x cos n pi x by L. It's n pi x by 1, so I didn't write that one. So use the Bernoulli's rule again. First function as it is into the integration of second function, that is sin n pi x divided by the coefficient of x, n pi, minus the differentiation of this function, 2. Differentiation of 2x is 2 and x square is 2x, minus cos n pi x divided by the square of this term, n square pi square, plus the differentiation again, 0 minus 2. Again the differentiation of cos is sine, there is minus n cube pi cube. Substitute the limits, 2x minus x square, 2 into 1 minus 1 square, that is 2 into 1 is 2, minus 1 square is 1, sin n pi by n pi, the value of x is 1, so sin n pi, minus 2 minus 2, 2x, right, 2 into 1 is 2, cos n pi divided by n square pi square, plus 2 sin n pi by n cube pi cube. How is 2 sin n pi again? 0 minus 2 is minus 2, minus into minus is plus. So 2 sin n pi, value of x is 1, divided by n cube pi cube, minus the lower limit 0. This term becomes 0. 2 into 0 minus 0 square is 0. 0 into any term is 0. So I have written 0 minus 2 into minus cos 0 by n square pi square, plus 2 sin 0 by n cube pi cube. We can cancel some terms here. Sin n pi term becomes 0. This becomes 0. Sin 0 term becomes 0. So this term also will become 0 because 2 minus 2 is 0. So now we have left with only one term. Again, minus into minus is plus. Plus into minus, we have minus sign outside, is minus. Value of cos 0 is 1. So 2 into 1 is 2. The final value of an is minus 4 pi n square pi square. Yeah, so this is the required Fourier series. a0 by 2, the value of a0 is 4 by 3. a0 by 2, so it becomes 4 by 6. So by simplifying 4 by 6 by 2 table, we will get the 2 by 3 plus summation of n tends to 1 to infinity, value of an cos n pi x by 8. So this is the required Fourier series. So we've solved all the problems related to all the intervals, that is minus pi to pi, 0 to 2 pi, minus L to L, 0 to 12, and we've seen the differences. We've seen all the deduction cases. We've seen all the limit cases, all the discontinuous cases. We've solved mostly all the problems, but there's one problem related to the e power x. I've told you the integration of e power x, e power ax cos bx plus c, right? I've given a set of formulas for that. So in the upcoming sessions, we will deal with those problems. So that's all for this session. We'll see you in the next session with the problems related to the half range series. That is half range sine and half range cosine series. So those are literally the easiest problems. It won't take much time. It is similar to these concepts only. And after that we have some wave functions, direct wave functions. There are no problems for that. There are a few derivations and some waveforms. So we'll see those in the upcoming sessions. So please, if you want the notes of this, I have told you before, you can go to the description. We'll provide you the notes for this. There is a website. You need to click on that website, and all the instructions will be there in that website. So please, if you want some notes related to these Fourier series, so please go there and click the link in the description. Also, if you like this video, please make sure you like it, and please share this to the group of any WhatsApp group or any student group, because these concepts are very important and the exams are coming near for VTU site. And please do share it, like it, and thank you for watching. So we'll see you in the next session.